Selected values of a function f are shown in the table below. Okay, hello table. Suppose n is equal to the average rate of change in f on the interval 0, 4. So let's quick do that. Okay, n is equal to the average rate of change. So n is going to equal f of b minus f of a. So you would be like my f of b, you would be like my f of a over b minus a. So f of b is 0, minus f of a is negative 8, so I have a double negative there, over b, which is 4, minus a, which is 0. So that's going to be double negative 8 over 4, and it's 2. Okay, got n down. P is equal to the average rate of change of f over interval 610. No, it's funny. NP are my initials and 610 is my area code. So you would be my new f of a, and you would be my new f of b, and you would be my new a, and you would be my new b. So P would equal f of b, which is negative 40, minus f of a, which is negative 16, over b, which is 8, minus a, which is 6. Negative 40, double negative becomes a positive, so we got negative 24 over 2, and that becomes negative 12. So n was 2, p was negative 12. Which of these could be a true statement based on the values of n and p? The function f could be a linear function because n equals p. Well, that's not even close. The function f of x could be a linear function. It's not linear. I know it's not linear because the rates of change are different, so I'm not even going to bother. The function f of x could be quadratic because n equals p, but n doesn't equal p, so no. The function f of x could be quadratic because n does not equal p, which is true. So if it's quadratic, the rate of change is always changing. This is asking for rate of change, and the rate of change is changing or has changed. So yes, this could be quadratic because the rate of change is not the same.